Hello friends, welcome back to our channel Adami Education. Like we promised yesterday, we are back again with the next part of the paper solving of 2026 physics paper. Today we are going to begin with question number 2, sub-question 1. State two factors on which the position of the center of gravity of a body depends. So this is from chapter number 1. So they have asked us the conditions or the reasons on which the center of gravity of a body depends. So the correct answer would be the shape of the body. We know very well that the shape of the body will influence the center of gravity. For different shapes, the center of gravity is different. The shape of the body would be the first factor. The second factor would be the distribution of mass in the body. The questions which are there in your book, the table which has been given in the book, in all of these it has been written a rectangular lamina or a triangular lamina. So in all the cases we have assumed that the mass is evenly distributed throughout the object. But if the mass on one side of the object is more and on the other side it is less, then the center of gravity will not be according to the table, it will be different. So another important factor is distribution of mass in the body. Let's read the next question. Case 1. Lata cuts a potato into two halves using a cutter which belongs to class 2 level. She needed effort E1. Okay. In the second case, then she cuts another half of the potato, but this time she needed effort E2 and it has been given that E1 is greater than E2. So first of all, we have to make the diagram of the second class lever. We know in case of a second class lever, the load is in the center, or the load is between the fulcrum and the effort. So let's consider the load is here. Okay, the fulcrum is on one side and the effort is on the other side. Let's consider it this way. So in the first case, the effort was more as compared to the second case. So we have to say in which case the potato was closer to the hand of the person, so that the effort would be according to the question, E1 is greater than E2. So in which case the effort, the load is closer to the hand of the person. Now we know one thing, that if the load arm and the effort arm are placed like this, we know the formula, effort by load is equal to load arm by effort arm. That means if the load arm is more, then the effort will also be more. That means if the load is placed at a higher distance from the fulcrum, then the effort that the person has to apply will be more, and vice versa. So if, let's consider, in one case the potato was placed here, the load was placed here. So automatically the load arm will increase, and if the load arm will increase, the effort will increase. So in which case the effort is more? In the first case, E1 is greater than E2. So this means that the potato is farther away from the fulcrum in this case, in the first case. So if the potato is farther away from the fulcrum, that means it is closer to the hand of the person. So accordingly the correct answer would be in the first case. And the reason will be, since increase in load arm will increase the effort, if the potato is placed close to the hand of the person, that means the load arm will be more, and eventually the effort will also be more. Hopefully I have understood this question. If such a question comes, you can also make diagrams to explain it to the examiner. The graph below shows the variation of image distance with the object distance when an object is placed in front of a lens. The graph below, it has been repeated twice, okay, no worries. So there is a graph given here which represents the relationship between the object distance and the image distance for a particular lens. We have to identify the type of lens used, and also we have to say what would be the magnification if the object is placed between f and 2f of the above lens. So we can do this first, but we have to identify the lens, and then the second question will become very easy. So what do we see? The object distance and the image distance are inversely proportional to each other. How do we understand this? Let me just zoom into the image. Let's consider this object distance. Okay, so for this object distance, let's consider this as x. Your image distance is this much, this small distance. This is the image distance y. Now if I consider this part as the object distance, okay, this much, a very small object distance, and see the image distance is so high. So from here we can understand very easily that the object distance and the image distance are inversely proportional to each other. That means if the object is placed at a given distance, the image distance will depend on it in the inverse manner. If the object is placed far away, the image will be formed closer and vice versa. So from this relationship, we can very easily say that this is a convex lens. If you consider the ray diagrams of a convex lens, this is what we are saying. When the object is placed between the focus and the center of curvature, that is 2f, the image is formed beyond 2f. And if the object is placed beyond 2f, the image is formed between f and 2f. So in this manner, we can say that the image distance and the object distance are inversely proportional. So this is the case of a convex lens. Now the next question is, what would be the magnification if the object is placed between f and 2f? So if the object is placed between f and 2f, the image will be formed beyond 2f, and we know that the image formed will be larger in size. So the magnification will be more than 1. Hopefully you have understood this question. Let's move on to the next one. A resistance R is connected across the cell with a switch and a rheostat in series. A voltmeter is connected parallel across the cell. Current in the circuit is increased using the rheostat. Okay. How will the voltmeter reading change? And you have to also justify the answer. So let's see what has been given. First of all, we have a resistance, that is R. We have a switch and a rheostat in series. Rheostat, if you remember, it is used for changing the resistance of the circuit, and accordingly the current will also change. The current will increase. What will happen to the voltmeter? So we know one relationship, V equals to IR. So if we use this directly, we are not going to get the correct answer. Why? Because over here a cell has also been mentioned. This relationship will be applicable when we are just using a single wire. But since we are using a cell over here, we have to use another relationship. So don't get confused and end up using Ohm's law. The formula which we are going to use is voltage is equal to EMF minus I into small r. So they have said that the rheostat is used to increase the current in the circuit. That means this part will increase, right? This is same. This is not changing. The EMF of the cell is fixed. So if this part of the equation will increase, obviously the reading of the voltmeter will decrease in order to maintain the value of the EMF. So the voltmeter reading will decrease. So what will be the answer for this? Since the current is increasing, the voltage drop across the internal resistance will also increase, this part. And as a result, in order to maintain this equation, we can say that the terminal voltage or the voltage which is measured by the voltmeter will decrease. Hopefully you have understood. So whenever there is a cell in the circuit, you have to use this equation instead of Ohm's law equation. Now the next question is very easy, directly from the book. Define natural vibrations. How is this vibration different from damped vibrations in terms of its amplitude? So what are natural vibrations? I am just dictating it to you orally. The periodic vibrations of a body in the absence of any external force, they are known as natural vibrations. If there are no external forces applied on the system, the vibrations exhibited by the body will be known as natural vibration. You have the definition of this directly given in the book. Now how is this different from damped vibrations? Now what are damped vibrations? In which the amplitude will slowly go on decreasing because there is an external resistive force which is acting on the body. So how is it different? The amplitude of natural vibrations will remain constant, right? It will go on in the same manner without any change. So if I draw it, it will look somewhat like this. This is a natural vibration, the amplitude is not changing. But if I consider the case of a damped vibration, slowly the amplitude will decrease and then it will completely become zero. Hopefully you have understood. A very easy question. Next one, a metal piece of thermal capacity 40 joule per Kelvin absorbs 800 joule of heat. Calculate the rise in temperature of this metal piece. So again, this is a very easy question. We know the formula. The thermal capacity is also called the heat capacity. Heat capacity is equal to the heat absorbed divided by the rise in temperature. So we have been given the heat capacity, that is 40. The amount of heat is given as 800. We have to find the rise in temperature. So the correct answer will be 20 Kelvin. This is the rise in temperature. Next question. In an AC generator, name the part which has the following functions. So Like we know very well, AC generator is a very important topic of your class 10 syllabus, and all the parts which are there in it, which you label, their function, their working, their requirement in the setup is very essential. AC generator and DC motor, both of them are very important, so go through that nicely. So the first question is, it will intensify the magnetic field. That means it will help us to increase the amount of the magnetic field. So this is done by the soft iron core, which is there in the middle of the armature coil. This will help to increase the amount of the magnetic field to make it more. Maintains the electrical contact between the rotating parts and the electric circuit. Again, this is also very easy. It will be the carbon brushes. If you remember, the carbon brushes are creating the contact between the various parts, between the rotating parts and the outer circuit. So the second answer will be carbon brushes. Again, a very easy to mark question. Let's go on to the next question. Give two differences between nuclear fusion and nuclear fission. Again, a very direct question from the book itself. So there are many differences. We are going to discuss the easy ones. So we know in nuclear fission what happens, it will break. So what will break? A heavier nuclei will break into smaller nuclei, and in case of fusion, smaller nuclei will join to form a larger nuclei. Okay, this is one of the differences. The other difference is nuclear fission is possible at ordinary nuclear fission is easily possible at ordinary temperature and ordinary pressure. For example, if you keep a block of uranium, it will easily show nuclear fission and it will break into the respective smaller nuclei. You don't have to put any kind of energy or pressure to it. But for fusion, for the process of fusion, you need to give a very high amount of temperature and a very high amount of pressure. So although nuclear fission is easily possible, but nuclear fusion requires a lot of energy and pressure. So the easiest differences, you can write it for your exam. Let's move on to the next question. A monochromatic ray strikes the surface of identical prisms A, B and C at different angles of incidence. The diagram below shows the refracted rays. So the original incident ray has not been given, only the refracted ray inside the prism has been given. Study the path of these refracted rays and identify in which of the diagram the angle of incidence is maximum, the angle of incidence is minimum, and the angle of incidence is equal to the angle of emergence. Let's start with the question number C, because that is the easiest one. We know one thing, whenever the angle of incidence will be equal to the angle of emergence, then we get the refracted ray completely parallel with the base of the prism. So option number C will be the correct answer for the third question. Okay, as you can see, the refracted ray is completely parallel to the base of the prism. This is only possible when the angle of incidence is equal to the angle of emergence. Now let's talk about the other two cases. We know one thing, the refractive index is equal to sin I by sin R, isn't it? Now it has been said that the prisms are identical to one another. That means the refractive index in all the cases is same. So from here, can I say that sin I will be directly proportional to sin R, because this part is constant. So this also means that if the angle of refraction is more, the angle of incidence will obviously be more. So from the diagram, let me just zoom it for you. You can see that the angle of refraction is more for this case as compared to A. So of course the angle of incidence will also be more for prism B as compared to prism A. So the angle of incidence is maximum in the second case and the angle of incidence is minimum in the first case. And this was possible only because all the prisms were identical to each other. Let's move on to the next question now. A ray of light enters a glass block from air and comes out from the opposite surface. If the angle of refraction at the first surface is not the same as the angle of incidence at the second surface, then what is the product of the ratio sin I is to sin R at the first surface and at the second surface? Okay. So we have a glass slab. A ray of light is incident on it. Then it refracts and it then again moves out of the glass slab. So let me draw the normal. This is the angle of incidence I. This is the angle of refraction R. Let me take this as R1. Now for the second surface, this will be R2 and let me take this as E. Now they have mentioned one thing, that the angle of refraction in the first surface is not equal to the angle of incidence in the second surface, which is generally the case for a glass slab which has parallel opposite surfaces. So if we consider the second and the third question initially, they have asked whether the opposite surfaces are parallel or not. No, they are not parallel. What is the reason? Because it has clearly been mentioned in the question that the angle of refraction at the first surface is not the same as the angle of incidence in the second surface. So obviously this means that the opposite surfaces are not parallel, because if they had been so, we would have got the two angles mentioned in the question as equal. But since they are not equal, we can also say that they are not parallel. Now coming to the first part of the question, we have to find the product of the ratio sin I by sin r for both the surfaces. So let's consider the first surface, that means this one, sin I, let me take this as I1, sin I1 by sin R1 is equal to mu, right? This is my equation number 1. Now for the second surface, sin R2 by sin E, because the ray is moving from here to here. So sin R2 by sin E, this will obviously be equal to 1 by mu. Now if I do the product of these two, what am I going to get? I am multiplying equation 1 and 2. So sin I1 by sin R1 into sin R2 by sin E will be equal to mu into 1 by mu, which is going to give you 1. So the correct answer for the first question is 1. Hopefully you have understood this. A type of glass block has refractive index 1.8. Calculate the speed of light in this glass. Okay, very easy one. We know the refractive index is equal to speed of light in air or vacuum divided by speed of light in the medium. So the refractive index is given as 1.8. The speed of light in air is 3 into 10 to the power 8. Even if it is not given in the question, you have to remember it. And you have to find the speed of light in the medium. So V is equal to 3 into 10 to the power 8 by 1.8. So if you solve it, you're going to get the answer as 1.66 into 10 to the power 8 meter per second. This is the velocity of light in the glass block. Now the next question is, what will happen to the speed of light if the width of the block is doubled? In the formula, can you see anything related to the thickness of the glass? No. So the speed of light will remain same because it does not depend upon the width of the object. Okay, this is what you have to write. Next question, name the electromagnetic radiation used to detect fake currency. So again, I guess this is a very easy one, you all will be able to do it. It is UV radiation. Okay, now the next one, we have to complete the ray diagram for this particular prism. So let me just zoom it a bit. The critical angle for glass has been given as 42 degrees, so we have to keep this in mind while solving the question. On the first surface, this one, since the ray is falling normally, so it will pass through without any refraction and it will go and strike the hypotenuse. Now let us make the normal on this surface. Now if this is 90 degree, this should also be 90 degree, and if this is 30 degree, this angle should be 60 degree. So obviously this particular angle should be 30 degree, isn't it? And if this is 30 degree, then this angle should be 60 degree, right? The critical angle of glass is 42 degree, but this angle is 60 degree, which means the angle is more than the critical angle for the given pair of media. That means in this case we are going to get total internal reflection. So let's continue. So it got totally internally reflected. This angle is also 60 degree and this angle is also 60 degree because it is reflection, right? Total internal reflection. Now when it strikes the third surface, now let's make the normal for that surface. Okay. Now again, how can we find out the angle at which the incident ray is striking the normal? This is 90 degree. This is 90 degree. This entire angle is 120 degree. So for a quadrilateral, let me consider this as my quadrilateral, this one. So if this is my quadrilateral, we know the sum total of all the angles of a quadrilateral is 360 degree. So from calculation, we can see that this angle is going to be 60 degree. So if this angle is 60 degree, the angle of incidence on that surface will be 30 degree, and since the critical angle is 42, the given angle is less than the critical angle, so it can easily get refracted, so it will refract and come out of the prism. I guess it is clear. It is very easy. You just have to remember the rules which you have to follow while making the ray diagram, and that's it. So I hope you have understood the session. Today we have done long answer questions along with some short answer questions, and tomorrow we are going to finish this paper solving for physics, and from the next day we are going to start with chemistry. So if there are any doubts related to the questions which you have done in today's class, please feel free to comment down below. Also, if there are any other questions which you want a solution of, please do write the question in the comment section. We are going to make a separate video for that. Keep studying well. Let's meet tomorrow for the next session of the class. Bye everybody. Have a very nice day ahead.